Hi everyone, welcome to the WINLAB seminar series once again. Our speaker today is Professor G.V.S. Raju, who is visiting us from the University of Texas at San Antonio. Professor Raju is a Life Fellow of the IEEE. He's also a distinguished professor at the University of Texas at San Antonio. He's going to be talking to us today about defending against attacks from malicious nodes in mobile ad-hoc networks.
Sir, thank you for inviting me here. Our PC hard disk went out just half an hour ago. So all the prepared slides. So I had to reconstruct in half an hour again. In my past life, I was in the intelligence systems area. I did publish quite a lot for many years. So then, you know, as you are a professor, you have to keep hunting for money. So you meet somebody there at DARPA or Air Force or NASA or NSF. So somebody has the money, but they don't have the technical expertise in that area, so they are able to work in this area. So we got a substantial grant from the networks area. So we formed a group and we got into this area. So we have been working on this area.
Before you start, let me move these chairs because I think, you know, I think they might, you know, if you want to have some space.
No, I don't. I'm glad to see all the young people here. I'm not a young person anymore. I'm a very senior person. I just want to talk today. In fact, this talk was asked by Ved and Narayan, but those are not here. So the topic was very similar to what Ved is working on in some aspects of it. So I want to talk about how do you, they're always very easy since these links are virus links, very easy to scoop IP address or MAC address and they catch onto the network. So it is a problem, and DARPA is something, especially in the ad-hoc networks, are very useful to them. So they have formed a committee and invited me and into that committee. And a few years ago, they gave industry about $30 million to make workable in this network. So I was in that committee and I came. So what I'm going to talk now is see, there are two core questions here. One is defending against the outsiders, and the other one is how to defend the people who are inside also they are troublemakers. They do false transactions, viruses, and all these attacks are there. The outsiders are, this is a, we'll talk about in a minute. So for outsiders, what we developed is called HEAP. HEAP technology that is very well accepted and it is already published in the I'll tell you why our technique is popular than the others from UCLA, Stanford, and other people have worked on this problem. And the one which is the most interesting is the insiders. They are hard to track, to detect them, and they behave for a while properly and a good person, good behavior, and you trust them, and suddenly they become untrustworthy. So they are hard to track, and how do you take care of these two first? So a lot of interest is in the second part, defending against the insiders. We developed a technique, a couple of techniques to defend. So that's basically my talk. The MANETs are useful for military as well as the disaster relief and sensor networks. We need varying levels of security. and there it can be used with clients of several routers, easy to enter and leave. You can leave a MANET easily and get out. You can drop or tamper packets or false packets and inject it or easy to launch attacks. This is they are self-organized in the networks. There's no central company. They can link it to the other one and keep going there. And this is they can be connected to the internet. And this is many of you might be knowing these two things. There are two types. One is open and closed. Closed MANETs are what the military is interested in. Open, anybody can use it. Any node can access the MANETs versus the only authorized node to access nodes. Closed are only authorized nodes can be network. One is the flat or hierarchical. So in the flat, everybody has the same rights, whereas in the hierarchical, they have different rights, depending upon what kind of rights we have. So this is the for outsiders, we developed a HEAP. I told you the insiders. We finished about a few months, a few years, a couple of years ago, application system based, now based, cloud based, and we will build a hybrid. Hybrid one is not yet published, so I won't be able to go into details in that, but the other two are published, so I can go into details. Okay, here what we do is, every packet is authenticated in this. Every packet that is coming out from each one. This is the hop by hop authentication. Stop an attack before it spreads. So we want to kill the attack right in the beginning, first one. And we want to conserve resources. It doesn't want to. So it's one of the few which works against denial of service or man in the middle. Most efficient, will show you. It's suitable for unicast, multicast, or broadcast. It uses a modified HMAC. That is the authentication technique. HMAC. Okay, if you are not a network person here, I know, but most of you are in the physical layer. It is the top layer is the application where you send it your email, and that one is converted into zeros and ones. Then it goes to the transportation layer. And it's a big email, it segments into pieces, and then attach the transportation layer header to there, so the other fellow will read the header. And the network layer is the one which routes all these packets and sends it to the guy where he is going. And the data link layer is the one which puts all these zeros and ones into the packet or frame and sends it there. And the physical layer is essential for any transmission. And if you know all this, it is okay. The heap is, the purpose of the heap is all the packets go through no matter what we are using the application, they all go through the network layer. So we catch all the information going out and authenticate it whether it is right or wrong, then only pass it through. So we felt it is appropriate to put it a heap, this network layer based one, below the network layer. So we have catch all the traffic going out the computer. So a lot of people have done authentication, secure routing, intrusion detection, key distribution. All these techniques are done, especially intrusion detection is done by artificial intelligence groups. They have spent a lot of time on that. And secure routing is people who do the network. Authentication is one which we are going to do. Many schemes are control packets. All the techniques there, they have developed so far are the only control packets they detect and cut them off, but they are never able to do it for data packets. So PSP schemes are Tesla, which is was developed much earlier than Ad-Hoc and Raju and Coach algorithm. These are the three companies that have done work. And Wade is working using Tesla, depending on Tesla, and Wade is here. And we show our technique is much better than Tesla or LHAP or Raju and folks or everyone. Tesla is concerned with the end-to-end authentication with the delayed disclosure. They don't tell you the key first they disclose, that's why the delay is high there. And prior lose time synchronization cannot cut denial of service. So Tesla cannot prevent denial of service. Okay. LHAP also similar one, low and coach also they have some drawbacks. The reason I'm having there are a lot of slides. And the outsider versus inside, thoughts from outsiders. Outsider packets must be dropped at first hop. And I told you outsiders can scoop the IP or MAC address, and they can eavesdrop on the traffic, compromise it. Insider can become an outsider. After a while, insider can become an outsider. This is here. The central node is, the node is here at the center. He is communicating with his 5 numbers there. So here the advantage is this. You are saying you are handling each packet. You know, the packet rate is very, very high, and you are handling each packet. So the one would think, because you are dealing with each packet, the time consumed, the overhead will be very, very high. I'll show you the overhead is not much using this packet identification. What we did is, if you see the HMAC, there is a, no, I want to mention here, there are 2 keys here. IK key is common to all 5 of them, including the A node, A1, A2, A3, A4, A5, all of them have the same IK key, but they have the joint key, IK, OK, A1, A2, A3, A4, A5, they're separate 2 keys. See, most of them, all the other people have used single key. We split into 2 keys here. So 2 keys will provide much more security here. The 2 keys, what we did is, if you see the HMAC authentication technique, H within parenthesis K times XOR with the OPAD and IPAD. So IPAD we used as 1 key, OPAD we used another key, and we hashed it. And if you see that, the here data packet is also we are hashing it. Whereas the other people did not hash the message itself. Data they are not concerned with only. Control packets only they are using. So we used 1 key for hashing the message, and also the iPad we used a joint for between the neighbors. So he's communicating with all his neighbors. So if you see the second step, step 1, which consumes most of the computing area, okay, the computing takes most of the time in hashing the message, the first part. This one, that is common only compute once for all the 5 neighbors, whereas this one is secondary, which is only hash value is a single value to hash next one. That's why computationally very doesn't take much more time. So HMAC uses 1 key, HEAP uses 2 keys, and we use here the simulation ODMRP for routing. The reason we use ODMRP is it is the only routing technique which uses not only unicast but also multicast, means you can send the message to everybody, not just one person. They were not, and the other people who did not do it, we did it for a multicast. And we used also at the transportation level, we used the UDP because we are testing here, not the TCP. And at the data link layer, we use 802 level data link simulation. And this is a continuous CDR source, continuous data source. We have each packet is about 500 data bytes, so you can see how much money we get. We have 100 nodes in the square root of 10 by 10 we use, each node is separated by 100 meters. So that's the grid we have. So we also asked the Tesla people, HEAP and Blue, the other people who have done work here, to provide us the parameters. So we want to compare our technique with their technique so that they will be comparable. They are good enough to provide us, and we use those parameters and simulated both HEAP as well as the Tesla, HEAP and Blue, all of them we simulated. The mean latency, suppose sending a packet. The packet is 1 hop up to 6 or 5 hops. We have 5 neighbors there. If you compare ODM is a pure rotation, there is no hashing or security are there. And if you see the Tesla, it is a red, takes much more latency than the others. Then the LHAP, and then loop, and HEAP is the lowest one. It does not take much delay in sending, despite we are using the data packets as well as the control packets we are controlling and providing security. Still, our latency is much less than any other technique we have used.
So actually, I have a quick question.
Okay.
So why do we see a latency less with HEAP?
Because we are using one time only HMAC. For the message, we are using only one time. If you use, if you are familiar with hash function, most of the time it takes, your message can be very long. Your computer takes time. Okay, here, I'll come back to throughput. I'll go to the next slide and come back to this. Here, if you see that once the packet rate reaches here, mean packet delivery drops, means some are dropped. Once the data rate increases, they can't handle and they drop the packets, these nodes. So after that they steady off because the packet delivery ratio is small. If I go back to the original one, that's why this proportional to the as you packet rate is increasing, the mean throughput is increasing, but after 25 packet rate, because the delivery ratio is going down, coming down. So if we have more than that rate, throughput will be suffered. And we need to mobility also, there is static case, this is mobile case, so the throughput is this. And you can see that our throughput is very high. Memory requirements here for how much memory is needed. You can see here, HEAP is at the bottom of it. The requirements for the memory requirements for us is much less than either Tesla or Ad-Hoc or loop. And conclusion says HEAP is half by half definition. Guards against wormhole, provides security for against wormhole, denial of service, man in the middle, imposters. So we have almost a foolproof security at the network, below network layer for all the time that's going on. So low memory and CPU requirement. And some of the tasks, if you are looking for a master's thesis or some other thesis work, those two topics are still nobody solved it. Bootstrapping in a network is still a very headache. We did publish some papers there, but still some problems that solved because somebody is looking for a master's thesis. The last future work, there are 2 items I gave you, maybe you can work on those 2 items. Then we finished the outsiders one. Now the insiders one, it is a very, very, there is still a lot of money is there. That funding is we are looking for. And a lot of work to be done because outsiders you can always suspect and you can handle them, but the guy who is inside you and neighbor to you, you think he is okay, but he's not okay. That is hard to handle. that's for the insiders. So we developed a hybrid trust management. We'll go into that. Here is a reputation system based. So here see some of these I did it, but my computer gave up. So some of the slides which I did not want it, but they are there. So I hope they should. Okay, the trust management system models are monitoring based one. That means every neighbor is monitoring each other. Like, so each guy is seeing if anybody is behaving well, and the reputation based system and the role based systems. Reputation based system and role based monitoring is some other people have done. My colleague, one of them, Dr. Bhopna, he has been working on neighboring nodes, possibly monitoring, and they found this is unreliable. You can trust, maybe they are colluding. They never know, they might be collaborating and they are not. They found neighboring nodes, monitoring neighboring nodes is not trustworthy. So we did a second reputation based one for the experience. Here, which trust management system would be used? Hierarchical, single administrative, or one level only. Role based is better. Hybrid also is better. You can use. In the reputation system, there is no role based, and the hierarchical multiple administrators. You can use role based as well as hybrid. With the flat, it means everybody has the same rights, and the reputation system, flat and close, also reputation system. So we are going to work on the role based, reputation system and role based. So next I will tell you the reputation system. Goal is protect against bad transaction from the bad. Applications are these techniques are good for peer-to-peer networks, file sharing networks, distributed networks, wireless ad-hoc networks, online auction network. Useful wherever the networks rely on node cooperation. Whenever you need one flow is cooperating with the other. Malicious nodes exist. Historical behavior indicator of future behavior. We tell whether your guy is good or bad. We watch him and see, we transact with him and see how whether he is trustworthy or not. And then based on that, develop a model on it. History of transaction records maintained, possible to access those records, and the encryption used to transmit reputation scores. Each one sends the other guy what is the reputation score. In fact, this is already here in the system. If you go to eBay, an auction system, they use these systems. eBay and this auction people are using this. So we put the EMLTrust, this reputation-based system, below the application layer. I know so far what I thought is more applicable to the ECEP, means electrical and computer engineering. This has a little bit CS and as well as ECE combination here. There is a mixture of things here. The other people I told you, Rehan is our PhD student. He was with me since when he was undergraduate. As honors advisor, and then he was with me last few years. And the other one is Dr. Korkmaz. He's a junior faculty member. He just joined. He used to work on the routing protocols, but since he got this grant, he joined us. He's working on security. They have some CS background than I have, so that is helpful because he has CS background. So we put it just below the application layer this all the insider attacks around it, not at the network layer or below, it is at the application layer. Okay. The RS conflict is there, that means they are communicating with other people. So the question is, I have the information about, I got information about Y or X, they both are communicating, from A, B, and C people, its neighbors. Is he a good guy? Can we trust him? Can we transact with him? So, 100% honest or correct feedback, no problems. 3 major challenges: fake feedback from non-existent transactions, dishonest feedback, and incorrect, noisy feedback. These are the troubles. Our problem solutions are support vector machine, SVM, for 2 and 3 attacks. First 2, fake and dishonest, dishonest and incorrect feedback. Our techniques, which we are going to develop now, is useful. But if it is a fake one, the first one, the role-based will be able to, because this person is not there, how can you get about that person, whether he is good or bad? It's all fake transaction. So we introduced called digital signature. That means you authenticate, you require a certificate, somebody else issue to you digital signature saying he is such and such a person, and somebody is vouching for him. So that is we'll introduce that one, digital signature certificate idea to take care of the fake feedback problem. So time there is a client and server, request service, accept request, he sees the credentials and sends the certificate, and sign PC, and then you get verified certificate. Okay. The general idea is collect any RS framework is collect data and apply the equation and get the output and saying yes or no. Some people in the past have solved this problem using eigenvalues, linear algebra, and so on. They have solved it. And trust guard is the one, these derivatives, and then they designed a system. And some other people who have worked in some of the image processing area, they use a Bayesian technique, usually data distribution. That is the related work. What we are going to use is SVM. By the way, SVM is used very heavily, is already accepted technique, that it is the best technique available today for categorizations, especially if you are in the area of Microsoft uses very heavily here categorization. Suppose you have customer service, every email you send, the machine categorizes and puts into what you're asking, and then experts will answer your questions. So SVM is the one, and Wade is the one who asked me to talk about this one. He said his students will benefit. I don't know whether they are here or not, or you're one of them. But he was particular about this SVM technique. I hope he learned something. See what in the early, it is a European technique. What they said is, I'll tell you a little bit deep in this technique, is if you know the something about times that t minus 1 in the past, you can predict the future. So that means if I observe you last few times, 10 times, 20 times, then I can tell you whether you are going to behave good or bad. So that's what our criteria is, and why the probability of malicious transaction, whether he is going to be a bad guy or good guy, observing him previous transactions in the past. And And it is proven in reference 70, if you want I can give you. SVM performs well on time series prediction. So how time comes into picture is how to relate the time in the MANETs to this behavior SVM techniques. That's what we have found and we showed you in a few minutes. I will tell you how to do that. SVM also approximates unknown functions well, and the SVM is resistant to noise and so on. So time series prediction is if you know a time since 1 to 10 or 11, and what will be the value at the instant, 12th instant. So that's the prediction. And this is the one. So the separation problem here is these are all good guys or good behavior, or the same person behaved this many times good, this many times behaved this way. Can we say, based on the history, can we draw a line, separate the instances? These are good guys, these are bad guys. This is the hyperplane, it's not one-dimensional plane, it is a hyperplane, n-dimensional plane. How do you draw a hyperplane? So this is a high solution or no solution. Sometimes we have no solution, we need to go to solution. So, small margin sometimes you can separate them to, or large margin, then there's no problem. Okay, how do we do that? These are also, some people have done a functional. It's very hard to separate the fine behavior of function like this. But if you make a transformation, linearly you can tell who is bad guy, good guy. So there are also people who worked on this and are mapping functions for years, and here mathematicians have worked on this. And they found the kernels which separate from a non-separation problem here to a separable problem there. So that's what the SVM does. It does separate from good to bad. The kernels used are either polynomial or exponential polynomials. These are the two types of functions they use. See that? That separates into two functions. X is good, G bad. I do not, if you are interested, I have several slides here. Here, the separating hyperplane is here, but some of them are on the border, some of them is good, and their separation is good. Later, if I have time, I'll tell you how to solve this kind of problem in behavior. Okay, in this problem, the SVM, the third task is feature selection. What are the features we need to select? If you are image processing or separating the three-dimensional objects, the features they select are the area, the different selection. Of course, if you are EC, you can say what frequency or what energy, what noise level. These are all the features you can use. So feature selection, so portion of malicious to good ones. They were all bad guys, and if you are a good one, you are outnumbered, and it's very hard to trust. Imbalance ratio, good to bad, constant or training set. So usually all these machines are learning machines, or you use a good long training set and train the machine so that when an unknown comes, it can tell you whether it is a good or bad or what type to the outcome. So where you would test set, size of data sets, how much data sets, how big it is, and so which is about 1,000 instances to do it. 10,000, 1,000 test instances we took in our simulation, generated by simulations, evaluation. Okay. The evaluation metrics are same as what others also do. Here, accuracy in text processing, if you have background, accuracy means the number of correct predictions to the total number of predictions. So if you have 100, how many are correct ones and out of the total? That makes it gives you the ratio, accuracy. Whereas recall, this is the important one, is true positives, means correct ones, to true positive divided by true positive to false negatives. So that gives you recall. The other one is called precision. Precision is true positive to true positive plus false positives. So those are the three parameters used in text processing, and we are using the same one as in this. Whereas the receiver operating characteristics are below that curve, it tells you whether your method is good or bad. Okay. We use the polynomial in our feature selection. Okay. Here what we did is time is divided into slots. Each feature corresponds to one slot. Future we define here the number of positive feedbacks divided by total feedbacks as a future here. We obtain this digitally signed feedbacks from people. Compute for each time slot the FI, that means number of positive feedbacks to the total feedbacks. We took 15 time slots. Okay, attack one is this. Everybody is good behavior, bad behavior is this. This is the pattern 2. The reason I'm telling you is good behavior for a while, bad behavior. He oscillates. The attack 2. Third one is similar to attack 2 but with colluded. Two of them are colluding. So attack 4, similar to attack 3 but with much more collusion, means many people are colluding there. Attack 5 is a combination of all 4 of them. And we did all these attacks to do the experiments. Okay. Classification error means good to the bad. Where are we? SVM is at the bottom, and TVM, trust guard is in the literature or in the industry is the standard now. If most of the eBay or many of the upcoming companies which are using trust guard as the basis for classification of it. So we thought our test for acceptance is if we can beat trust guard, we made it. So we took trust guard as a TVM is there I have 2 of them, one is an IE, one TVM is in advanced. We also beat even the advanced trust guard one in terms of classification errors.
So your y-axis means that for the naive one, in the worst case, you have 35% error, classification errors. And what does TVM stand for? TVM, what does it
The
stand for?
advanced trust guard. I forgot, but they have included. You want to?
Excuse me. Please elaborate on why, as a percentage of malicious nodes increase, sometimes the custody error drops. So, why these curves present multiple nodes?
We found once it passes about 55 to 60%, in some cases nearly 70%, everything looks bad. So this is the malicious nodes. As increase the percentage of malicious nodes, the behavior changes abruptly.
counts more than 20.
No, after more than 60% if it is there, you can't make any sense.
Why 60% count the turning point in this course?
That's a good question. You are talking about my technique or their technique? See, these two are their technique. That's what my, the low as we increase the error increase.
Right.
There's no problem with understanding my technique.
Right, as to the
But
ends,
this,
where we can, the other two seems to be a little bit weird.
yeah. Well, I can't answer for them. I just give you the results what they.
See, I think like, if you look at the point 80, that's 80% of malicious nodes, and it corresponds to classification error of 20%. So in that line, or at that point, you probably just say everybody's malicious, and you have 20% of error.
In other words, you're not naive anymore.
But that's naive, right?
Yeah, that's what it is.
That's naive enough.
I'm a little bit off balance also, because just before the half an hour, my computer broke. Even even said he can't repair it. He said dump it. So he got it from the net. So I'm sorry.
It's fine. Thank you.
And I wrote notes, everything, comments on that. These are classified attack 2. For attack 2, these are results.
I think any kind of binary estimation that you try to do and the probability is greater than 50%, it becomes differently looked at.
We can just say no in this case.
This for 3, 4, 5. This is the ROC curve. So this is a guessing. It is a guessing. 50% is good and 50% is bad. The other one, L, is SVM. That means attack one is good or bad, so if it's good, it's good. So I'll keep the next one. Yeah, for attack 2, these are the curves for all 3 of us. The ROC curve means the area below the curve will be the percentage of good. For attack 3, 4, 5. Bandwidth consumed because there is communications going on between the feedbacks. It requires bandwidth for communications. SVM is very low bandwidth. MAU, you compare with MAU, TM takes a lot of correspondence. Okay. Okay, what we did is afterwards, with people, we got information from eBay. Seems people behave for a while good, bad, good, and bad. So if we have oscillating behavior, there, if you just use the technique I use, some people can cheat it. So so what we did is in the fading memories, we not only go, see, suppose 15 features, you are looking at the behavior only 15 time slots. So how to increase the time slots to observe? So what we did is fading memories means the nearest time, the last hour is behavior is important. Second hour or third hour is less important. maybe a few days ago, less important. So what we did is, we averaged as we go along. That means we average old ones, lot of slots into time slots. In a minute I will explain.
Conceptually,
Okay.
again, every time you do some action, there's some, what you call transaction cost.
Yeah.
So if you don't account for that, right, then somebody might just wait forever until the transaction, the benefit is huge and just do it once, right? And that's not it.
Okay. So in the shading memory is what we did is, your features are at each time slot here. Here what we did shading memories is in the FTD0 with only immediate time slot. If it is in the next one, we take 2 snapshot average. In the next one, we take 4 and average. In the next one, 8 and average, and so on, so that you can go time much more longer time to observe the behavior and to predict better behavior. So this is the average values you use in the first instance, second instance, third instance, and so on. We use this technique to observe them without increasing the features. That means 15 features we want to keep 15 features because otherwise dimensional SVM will be very hard. So we did this by averaging and taking this time out. And we, for small intervals, the behavior is almost the same. Whereas if we variable for a different attacks, okay, some slides are missing. I want to take it out and just go on. Okay. Again, come back. People, at least grade students, they ask me to tell me about this one. Okay. The linear equations, remember then the SVM hyperline is divided in good and bad. This is the equation for W is the perpendicular vector to the X is your variable. Your class being the constant. So if it is greater than this, it is a positive class, and if it is less than that, it is a negative class. And B constant plays a very important role here. I'm sure some slides are missing here. By picking, what I'm saying is by picking a proper B value, you can even classify properly which are on the borderline. So you can't classify as positive and negative. To find the B's, you have to have some guess of how much percentage are malicious, how much people are good ones and bad ones. You have to have a rough idea. Then you can estimate B. Then if you use it, the classification accuracy will increase tremendously. I wanted to tell later, but if you look, student of it, I want you to tell me. Well, I'm saying computer integration, different segment conditioning inside. You can read it. Time's up. Well, I'm claiming EMLTrust is suitable for MANETs, online centralized trust, third party required, no third party. I'll go to role-based now. So it occurred to us, maybe you can, this is not an EC problem, this is a CS problem. When you have given access to you, to a system, they give you, RBAC is very popular in controlling, especially computer security, how to give access to a computer for usage. That is, in fact, it was very much developed by the university near Washington, what is it? In Virginia. George Mason. They developed RBAC, and the government approved it. They introduced the RBAC, introduced keynote impersonator. So what it does is it gives credentials and assigns roles. If you have access rights. I think Linux, if you use it, you have those rights. If you're a student, you have only certain access rights. The others are not. It combines RS and work and drawbacks are both implemented. Algorithm for processing service request verify signature of client signature. Required privilege if we have a cable. So I think it's not for this audience. I want to just say we have this. The reason I'm skipping is I don't know whether I can, because this is authored by me and two others. Okay. This is not yet published. The others are published. This is accepted for Milcom. We also sent it for journal publication. That we didn't get answer whether it is accepted or not. But Milcom accepted, and so I purposely deleted some of the slides. But I am giving conclusions, so I don't breach their trust, as is covered by the other two others too. So what I'm doing is just making a claim here. Algorithm or processing service required verify signature on client service. Required privilege is maximum and denied service. Required privilege is that grant service. These are common sense rules. And you can calculate privilege is maximum privilege to the minus minimum privilege multiplied with reputation score. That's minimum privilege will be your privilege score based on the you give them access authorization to what level to give authorization. It's a control. Again, I thought these are all deleted. That is accepted now. Well, I'm sorry, the last portion, I didn't give details, nor I presented much, but partly because of some of the slides I couldn't get them, and other reason is I don't know whether I should reveal it. If I am the sole author, I don't mind revealing it. Somebody else is co-author, so I don't know.
Do you have any questions?